So in this example, I'm going to show you an application problem involving a quadratic equation. And quadratic equations can be used in application perhaps more often than you'd think. So quadratic equations have built up a nice reputation in physics of demonstrating the location of an object in motion when projected upward off the ground and then gravity pulls it back down. For example, shooting a basketball into a basketball hoop. The path that the basketball takes is the shape of a parabola and can be investigated via quadratic equations. Here is a different example where a quadratic equation is actually used in regulation, and this is actually pretty typical as well. So if I read the problem to you, it says, according to the Federal Aviation Administration, the maximum recommended taxiing speed, x in miles per hour, for a plane on a curved runway exit is given by this equation, where the variable capital R is radius of the curve in feet. Find the maximum taxiing speed for planes on such exits when the radius of the exit is 450 feet. So when constructing runways for planes or roads for cars, there are regulations on how tight a curve can be for certain speed limits. So here's a great example of that. So here's what we're going to do. We need to find, whenever you're reading a problem like this, you need to identify what's being asked of you. So we're being asked to find the maximum taxiing speed for planes on this particular exit. All right. And that max taxiing speed, the maximum recommended taxiing speed, is given by x in miles per hour. So basically what we're being asked to find is x. But we're not just being asked to find the value for x in general, we're being asked to find the value for x when the radius is 450 feet of that exit. So the radius is 450 feet, and we know capital R represents the radius of that curve. Okay, so find the value for x when capital R is 450. And notice they gave us 450 feet, and capital R is supposed to be in feet, so R is 450. Okay, so we're going to use this equation right here. R equals 0.5 x squared, and I know that R should be 450 in this example. So I want to solve for x. I think what I'm going to do is divide both sides by 0.5. And when you divide by 0.5, which is the same as a half, you're really multiplying both sides by 2. Now, if I were using a calculator, I could certainly type in 450 divided by 0.5. That'd be fine. But 450 times 2 is 900. Sorry, this is x squared. Good. Okay, so I have something squared equal to 900. I really want to know what that something is, so I'm going to take the square root of both sides. And when I take the square root of both sides, I'm really using the square root property, so I need to remember my plus or minus. So the square root of 900, this one's not too bad. That is 30, so I really have plus or minus 30. Now, since this is an application problem, you really need to consider the context before you provide your answer. So let's look at the context. X is representing speed, how fast the plane is taxiing, and speed is generally not negative. So I really don't want x to have a negative answer. It should just be positive. So X should just have a positive value when I give the answer. So the maximum taxiing speed that this plane should take is 30. And it's really important to know the units on that. Is it miles per hour or kilometers per hour? In our example, it is miles per hour. So 30 miles per hour, also abbreviated mph, is the maximum. We know it's the maximum because it said that's what X is. X is the maximum recommended speed. Recommended speed for taxiing a plane around a curve of radius 450 feet.